So the big picture for this lesson is graphing rational functions. And I think the most beneficial thing I can do for you is just talk you through the content in the lesson. And keep in mind, this lesson is about graphing rational functions by hand using pencil and graphing paper. And it's not about using a calculator, although calculators can be used to quickly check your graph. If you graph them by hand, you'll have a better understanding of the features of the graph and why they behave the way they do. So start off here. You'll want to write all this down on slide 2. This is the process for graphing rational functions, and you're going to be using it throughout the lesson. So definitely take some time to copy notes on this. So here's an example. Graph f of x equals x divided by x squared minus 4. First of all, you do the x-intercept, set x equal to 0. And x equals 0 is the intercept, so that's your blue dot there. Determine the vertical asymptotes. You set the denominator equal to 0 and solve. You get x equals -2 and 2. Those are these red vertical lines here. Determine the horizontal or slant asymptotes. The degree of the denominator is greater, so that means y equals 0 is the horizontal asymptote. So the next thing you do is make a table of values, as you can see here. Do a couple points on each side of each vertical asymptote, so it's kind of like there are 3 chunks to the graph here. And then those points give you a foundation for drawing the curves that do follow the asymptotes. And the curves look like this. Here's another example. In this case, notice the degrees are the same. So that means it's going to work out a little differently than the last graph. But the steps are all the same. First of all, determine the x-intercept, set the numerator equal to 0 and solve. X equals -1 and 3. Plot those points. Set the denominator equal to 0 to get the vertical asymptotes. You get x equals -2 and 4. Those are the red vertical lines there. Horizontal asymptote. The degrees are the same, so you divide the leading coefficients. 2 divided by 1 is 2, so y equals 2 is the horizontal asymptote. Find some coordinates on each side of each vertical asymptote. And that creates where your branches are going to be. And then your branches look like this. They just follow the asymptotes. Here's one where the power in the numerator is greater. Same steps though, determine the x-intercepts. There are 2 of them there. There are 2 of them there, -3 and -2. Set the denominator equal to 0, solve to get x equals -1. There's your vertical asymptote. This one has a slant asymptote because the degree of the numerator is greater. And what you do is you do your division, and you find that you get y equals x plus 4 is the asymptote. Then you do your coordinates on each side of the vertical asymptote, and then draw your branches accordingly. The other concept in this lesson is a hole in a function. When you have a common factor in the numerator and denominator that contains the variable, like this x minus 2 divided by x minus 2, you have a hole in the function. That means 2 is not in the domain. However, it's not an asymptote situation. It's just a little hole in the graph. It's missing. And if you're graphing on your calculator, you'll see error for the y1, and that's what's happening here. There's a hole at 2, 0.5. However, if you simplify it to x plus 1 divided by x plus 4, that doesn't show an error because the common factor has been divided out. And here's how a function hole is represented. Usually you have a little hole right there, just like that. So how do you determine the hole of the function? Well, what you do is you figure out the x value that makes this factor equal to 0, and then you input that into the simplified function, and that tells you what the coordinate is going to be. So in this case, -1 makes this a 0. So -1 is your input here. You input -1, see what you get. In this case, it's -4/3. That's the y coordinate of the function hole, and it will fit right along the curve for your function. So that's the big picture for this lesson.